Okay, guys. So let me repeat again. So it will be in recording, chapter 7. We'll not finish all of this, a lot of a big chapter, but at least we have 10 minutes. So what is the difference between bonding, covalent, and ionic or covalent bonding or compound? So it turns out to be, if I speak about covalent, I speak about a combination of non-metals. You cannot have metal there. The combination of what? Of non-metals. In this type of covalent bonding, they share what? They share their own valence electrons. They don't transfer to each other any valence electrons. The bonding, the ionic bonding, on the other hand, they transfer their valence electrons from the metal to the non-metal. The metal is always cation, and the non-metal is anion. So ionic is transfer of valence electrons from the metal to the non-metal. So the non-metal. So here we have sodium. Sodium is, if you like this sodium, correct? It has 10 protons and 10 electrons, correct? Overall, the charge is 0. That's a neutral sodium. Now, when it gives away 1 electron, so this is sodium plus lost 1 electron, correct? So it's really lost 1 electron. So 10 protons and 11 protons to begin with. Now it has 10 electrons because you lost 1. So therefore, it will appear as positive. So in ionic compounds, the cations are the metals. Cations, those are positive here, are metals. Correct, guys? The non-metals, on the other hand, will accept this electron. So this one here, 17 protons, neutral, correct? Now it's getting this electron here is given to what? To electrons. So now we have 18 electrons, not 17, neutral. Now we have 18 electrons. So we have fluorine is being what? This is anion. So this is what? This is anion. And this is negative. So ionic bond, you have to have a metal. So this is characteristic. You have to have metal. Metal, combination of a metal and non-metal plus non-metal. It can't be non-metals more than 1. It does not let me write very well. So now let's take the other slides here. Here, this is the same thing we did with the valence electron. Remember, valence electrons, the outermost, they are number of the group. Valence electrons are outermost, they are number of the group. So if I look at this, valence electrons are what? Equal to number of the groups. So 1A, number of the group. So 1A, since the group number 1A, so they will have valence electron 1. 2A, valence electron is 2, and so on. 7A is 7. 8A, you have 8, correct? So, and this is just electron configuration of the valence electrons. Okay, so here's the ionic compound. Why is ionic? Well, we have a metal here. This is a metal. The metal does not share its valence electron. It's giving away its valence electron. So it's giving away, it will appear positive, correct? Positive. And the non-metal is accepting this electron, it will become negative. So this is the non-metal will appear negative, correct? So this one here called, giving away its valence electrons, you have a positive. And this one is taking this electron here, Look at this. Taking this electron and will appear then negative. So if you look at the whole thing here, so you have this called, has a name, this called lithium fluoride. Lithium fluoride, called what? Lithium fluoride. And this type of structure called Lewis dot structure. So this is Lewis dot structure. So this is called Lewis dot structure. Lewis dot here, dot, sorry. So Lewis dot structure. So this is lithium fluoride. So let's look at this further. This is, I'll just give you, you don't have to worry about. This is because when the lithium positive comes to the negative fluoride, they come together. And then the charge, the positive charge and the negative charge, this is for the cation here. You don't have to worry about this. This is the cation, this is the anion, and the difference between them multiplied by the radius between them, that will give you the lattice energy. So we have to not to be worried about now. This is when you go higher chemistry, then yes, calculate the lattice energy. But at least you know each one is accommodated with its energy. That's not repulsion, attraction, positive with negative. So here, let's show you here. Fluorine here, you have 7 and 7. You can combine them. That's covalent. That's covalent. We don't, they share. So they here, they share what? They share the 2 electrons here, sharing. Covalent means sharing. So this is sharing. So they share this electrons, correct? And the bond in between them called single bond. Here it is called single covalent bond or called sigma bond. So it has 2 names, sigma bond, or called single covalent bond, correct? So they are sharing. So this is what? This is covalent. Covalent means to share. They are sharing their valence electrons. They are what? They are sharing their covalent bond. They are sharing their valence electrons. So I'll stop in a couple of minutes. Just let me just go for this one here. This one just an example. If you have the covalent compound can be done by combination with many nonmetals. This is nonmetal. This is nonmetal. This is nonmetal. So you see they are sharing here. Hydrogen is shared with oxygen. And here another hydrogen shares with oxygen. So you have 2 sigma. You have 2 single bonds or 2 sigma. 2 sigma bonds. Correct? Here the same thing, double bond. You can have those 2 together. We have double bond here. You have sigma, single bond. You have double bond, and we have sometimes a triple bond. I'll stop here. We'll come back and look into this when we come back. Those who came late, the quiz 3